Hi guys, Dr. Musk back again. We've skipped one section of the textbook 16.7 because it's not really important to understanding the reactions of aldehydes and ketones. And we have a lot of chapters to cover, so there are little things that we're going to gloss over a little bit. But it is very important for us to understand this reaction of aldehydes and ketones. So we can add alcohols to aldehydes and ketones to turn them into, specifically, we're going to worry about acetals. So what happens is we exchange carbon-oxygen bonds. So we break both those bonds between carbon and oxygen and replace them with single bonds to a different oxygen. All right. Now I'm going to try and color code this just a little bit, although it looks like the book's done a pretty good job here, or the PowerPoint slide's done a pretty good job. So imagine we started with acetone. All right, a very simple ketone. And imagine that we are going to add an alcohol, and H2SO4 is just a catalyst. So let's make that alcohol a different color here. So what if we used methanol, CH3OH? In the end, what's going to happen is we will end up with those same three carbons from acetone, but now we will end up with a pair of bonds to two of those CH3OHs. Now note that we had to get rid of that hydrogen that's attached to the methanol in order to attach it to the carbon of our acetone. But this thing that we have here is what we call an acetal. So it's almost like we have a double ether, all right? Two oxygens with alkyl groups bound to the exact same carbon. Now we can't just call it a double ether because acetals are much, much more reactive than ethers are, all right? So in general, whatever aldehyde you have and whatever alcohol you have, you're going to add two of those alcohols in place of the carbonyl. All right, that's how you're going to get your acetal. Don't worry about hemiacetals at all, because other than some very specific cases, we're never going to stop at adding just one alcohol. We're going to add two of them to make the acetal. So here you can see an example with an aldehyde where we add ethanol to that aldehyde, a 2-carbon alcohol right here. Don't worry about after we've added just one of those ethanols because the reaction never stops there. In the end, look at the beginning and what we have at the end. We break both of those carbon-oxygen bonds and replace them with bonds to two of those methanols. All right, sorry, two of those ethanols. And that is how we get our acetal. So let's look at a couple more examples of acetal formation, and then we'll be done with chapter 16. What if we started with this aldehyde and then treated it with that alcohol in the presence of our catalyst H2SO4? So take just a second and see if you can write the correct structure of the acetal that would result from that. Don't worry about the hemiacetal. Worry about what happens at the very end. Remember, we're going to break both of those bonds between carbon and oxygen and replace them with a pair of those alcohols instead. All right. So once that happens, you get something that looks like this. Now note that I didn't show that hydrogen that was there at the beginning. It is still there bound to that carbon. It's just I don't show it because it's a hydrogen. We can leave that out from our bond line drawing. So there's the acetal that we get by treating benzaldehyde with 2-propanol. Do one more together. What if we have a ketone and we treat that ketone with Let's do a very special alcohol here, ethylene glycol. So note that in ethylene glycol, there are two OH groups. And if we replace those two bonds in the carbonyl with bonds to oxygens, we can use both of those oxygens to form new bonds to that carbon. So in the end, our acetal is going to be a cyclic acetal. It's going to look like this. Let's try one more together. What if we treated this aldehyde with that alcohol in the presence of H2SO4? So again, we have two OH groups on that alcohol. So we can use both of those to substitute for those two carbon-oxygen bonds of the aldehyde. And we're going to end up with something that looks like this. And in this case, I'll be nice and just show that exact same hydrogen from the aldehyde functional group. It's still left there after we convert that aldehyde into our cyclic acetal. So if we count our carbons, 1, 2, 3, in that diol, those 3 carbons, 1, 2, 3, are also there in our cyclic acetal. All right, so that is how we transform aldehydes and ketones into acetals. And whenever we have an acetal, we can treat those with water in the presence of H2SO4, and that undoes the reaction. It converts the acetal back into the aldehyde or ketone. So if we have an acetal that looks like this, so that's the acetal we would have gotten by turning that ketone into an acetal with methanol. Treating that acetal with water and H2SO4 gives us back our ketone and our two equivalents of methanol there. All right, I think that's all of our reactions for chapter 16. So hopefully we'll get to practice some more in